3-bromo 2-chloro 5-ethyl 4,4-dimethyl-octane. I know it will look like a magic for you when you are being presented with this, and you may be asking, how did I manage to name this? Okay, in this video we are going to learn how to name organic compounds. We are going to follow some rules that will help us to name organic compounds. There are 3 things I would like you to know in order to name organic compound. One of them is the substituent or the parent name. The other is the functional group. In naming things in English language, this word substituent represents what we call prefix, whereas parent name represents what we call root. The functional group is what we call the suffix. To name compounds, these 3 things must be there in organic chemistry. So this name 3-bromo 2-chloro 5-ethyl 4,4-dimethyl-octane contain substituent, parent name, functional group. Now, which of them is the substituent? Which of them is the parent name? Which of them is the functional group? 3-bromo 2-chloro 5-ethyl 4,4-dimethyl are all the substituents. What we mean by substituents in this organic compound is derivatives, a branch out of the longest chain. For instance, this. If you trace this like this, all those ones that branched out that are not hydrogen, there are other elements apart from hydrogen, we call them branches. 3-bromo 2-chloro 5-ethyl 4,4-dimethyl are all what we call substituents. The next word is the parent name. The parent name is just the octane if I exclude the E. Sometimes people include the E as that, but for me, to make it perfectly well, we exclude the E because the E means that we are discussing hydrocarbons. I don't know if you get me on that. Now, the functional group is that E that make us to know that we are discussing the hydrocarbon. Now, we are going to learn how to get this substituent, parent name, and the functional group and insert it to get this our 3-bromo 2-chloro 5-ethyl 4,4-dimethyl-octane. There are rules we are going to follow. The first rule here I'm giving you is identify the longest carbon-carbon chain. Let me tell you, if the longest carbon-carbon chain number is 1, we say it is mert. If it is 2, we say it is earth. If it is 3, prop. 4, but. 5, pent. 6, hex. 7 is hept. 8 is oct. 9 is non. 10 is deck. 11 is on deck. And 12 is dodeck. We have 13 to be trideck, 14 to be tetradeck, and so on. And if you can just get up between 1 and 12, I believe you are good to go. Now, we need to apply this rule in this compound to get it. Look at this. We are looking at carbon-carbon chain. We are going to count them. We have 1, 2, 3, 4, 5, 6. We are having 6. We go again. 1, 2, 3, 4, 5, 6. We count again. 1, 2, 3, 4, 5, 6. We can go again. 1, 2, 3, 4, 5, 6, 7, 8. From this, we know that the longest carbon chain is 8. Therefore, we are going to write it out that the longest carbon chain is 8. Here it is 8. We are going to call it oct. Therefore, the name of carbon-carbon chain number 8 is oct. My first rule has been obeyed. The second rule says identify the type of carbon-carbon bond present in all the bonds. Now, if it is all single bond, use the word an, but we pronounce it as n, an, n. If it is one double bond that is present in that compound, we are going to use the word in, although written as en. If it is two double bond present, it is diene. If it is three double bonds present, it is triene. If it is a triple bond, it is yin. And if it is two triple bonds, we are going to say it is diene. And the next thing to do is we are going to combine the first rule and the second rule together to get our third rule, which I call the parent name. Let's do it one after the other. Here, if you look very, very close, you will notice that they are all single bond. There is no double bond present here. Since they are all single bond, we are going to say that it is an, that is n. All single. If you remember, I said that we are going to join the rule 1 and rule 2. That we're going to join this and this. We will have octane, which is the parent name. We searched throughout this, we found out that there is no other special functional group. What we mean by functional group is a group of atoms that determines the character of an organic compound. There's nothing like that. Something like OH, something like COOH, something like COOC. We do not see something that looks like that. Therefore, since we do not see that, it means that this is coming from a hydrocarbons. Since it is coming from a hydrocarbon, the functional group here is the hydrocarbon, which we will name it as E. So combining the oct, an, and E, we will have octane as the name. The next thing is to look for the substituents. Since we have gotten the parent name and we have gotten the functional group, let's go for the substituents. The fourth rule I have here is number the carbon atoms which we have agreed to be the parent chain in such a way that it gives any present substituent the lowest possible number. Okay, now what we are saying here is that if you look at this here, you know we are using 8, that is the oct. If we count like this, 1, 2, 3, 4, 5, 6, 7, 8, we will have something that look like this. Okay, if we count it the other way around, we will have something that look like this. That is, if we are counting from left to right, we will have something that look like this. The red represents moving from right to left in our counting to get 8, and the blue represents moving from left to right in our counting to get 8. Now, if we look at it, which of the number that is closest to at least one branch? From here, if we move from this, it is 4 that is closer to a first branch if you are moving from the right hand. The last of the branching is 7. But if we are counting from this, we have 2. The number 2 is less than the number 4. Therefore, we are going to use the 1 down as the real way of counting it. Therefore, we are having here 1, 2, 3, 4, 5, 6, 7, 8 rather than this. Now, what do we mean by chlorine position 2? We call it 2-chloro. That is the word chlorine changed to become chloro. And the position 2 becomes 2-chloro. Therefore, the first one I'm picking is 2-chloro. The next one is 3-bromo, that is this. The next position is this CH3, CH3. Every CH3 is called methyl. You know, it's only one carbon here, one carbon here. It's supposed to be from met, and since it is lacking one hydrogen from alkane, it is called alkyl. Therefore, this is called methyl. This is methyl. There are two methyl here. Therefore, we are going to have here. This is 2 carbon, which is earth. The branch is with 2 carbon directly, but this one are not direct 2 carbon. This one is carbon up, carbon down, but this one, the 2 carbons are all down. Therefore, we say it is earth. Since it is shortened with 1 hydrogen, we call it ethyl. The position we are seeing it is at position 5. So we will call it 5-ethyl. There is no other substituent present in this compound. Note that it is the numbering that helps us to know the positions that we had here. Okay, the next thing to do is to name these substituents alphabetically without minding their prefix. But before we go there, because of this word prefix, you notice we have 4-methyl, and we can just say it is position 4, but there are 2 words methyl here. Therefore, we can change it to become, that means that at position 4, we are going to notice 2-methyl there, which is dimethyl. Now, let's name this. Remember, to name it, we start with substituent first, parent name second, functional group third. And we have already gotten the parent name and also gotten the functional group. The only thing that remains is the substituent, and we are going to name this alphabetically. By alphabet, B comes before C. Therefore, we are picking 3-bromo first, followed by C, which is 2-chloro. Now we are having 3-bromo, 2-chloro. Now between dimethyl and ethyl, D comes before this, but we are not looking at this di, rather we are looking at the methyl. Therefore, we pick E first. So we are having 5-ethyl. The next substituent is the position 4 and position 4 of a dimethyl. So we have, these are all the substituents. Introducing this octane here, we will have 3-bromo, 2-chloro, 5-ethyl, 4,4, dimethyl, octane. You can see that you can be able to name this. Then you can follow my pattern. There are also some other rules that we also need to follow, and those rules I'm going to insert them when we have a question or example that look like that. Let's try another example. Remember, we are to have these 3 things in our head: the substituent, the parent name, and the functional group. So we are going to look at the parent name. And remember, I said that there is a law that we missed, and we are going to apply one of the law here. Let's start with the longest carbon number to see what is going to be. We are going to have something in this nature: 1, 2, 3. No, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Therefore, the highest value we are having here is 8. Therefore, the longest carbon number is still 8. So the name of the longest carbon is going to be oct. If you look at it, you notice that we have a double bond here. We have a double bond here. Having this double bond have made this thing to be en. If you look at it, there is no special functional group. Therefore, it is more of the hydrocarbons. Therefore, we're going to use E as the functional group. The parent name becomes octane. But the thing here is that there is a position where this double bond exists. This is carbon 1, carbon 2. That is going to be at position 2. Therefore, the bond type is going to change with position. We are going to have it as, so the parent name including the functional group becomes, so we have octane. Okay, the next thing to look for is the substituents. The substituents are a problem. Therefore, the next thing to do is to number this. Look at this. We have actually gotten that the position is 2. Therefore, we can start the numbering like this. If you count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Therefore, we have 2 ways of counting it. But which one is the correct way? If we are counting it like this, we may have problem. If we count it like this, we may have problem. So we need to check. Let's number this and see which one is the correct way of numbering it. Then if we look at the numbering, we are going to have 1, 2, 3, 4, 5, 6, 7, 8. We also have 1, 2, 3, 4, 5, 6, 7, 8. If, for instance, we are using this, the rule says that since we are having equal length parent name here, we are going to make a special selections here. The selection will be based on the chain which has the greatest number of side chains. Now let's count it like this and know how many side chains do we have. Moving like this, we will have only 1, 2, and 3. But if you are moving like this, let's count. We are having 1 chain, 2 chain, 3 chain, and this last one which is 4 chain. Therefore this is the best way of counting it. Therefore we are going to have it as, then we can now name the compound by bringing out the substituents. Now if we look over here, we have a methyl here, a methyl here, and a methyl here. Therefore we are having 3 methyl. One is at position 2, one at position 4, one at position 7. So we have 2, 4, 7 trimethyl. Tri because there are 3 methyl group there. Then if we look over here, when we counted like this, we did not count here. Therefore we have 1, 2, 3. 3 in this is called prop. And since it is lacking 1 hydrogen, we call it propyl. So we have the position 5 to be propyl. According to naming, according to alphabetical order, M N O P. That is, M comes before what? P. Therefore we are going to name this first before naming it. Therefore we are going to combine the substituent and the parent name and the functional group to have what we have as. Notice that I put commas here, but I put hyphen here when I'm connecting a number and an alphabet. This is the substituent. Then we combine it with this. We will have 2, 4, 7 trimethyl 5 propyl octuene. Okay, let's go for the next one. Please, before going further, I urge you to name this compound you're seeing, starting from the activity 1 to this point. Then, you know what we're going to do? We're going to look for the substituent name, parent name, functional group. But according to me, I first of all go for the parent name, functional group, join them together, number them, then I go for the substituent so that I can know the position of the substituent. Then I combine the substituent name with the parent name and the functional group. Now from this, we are having 1, 2, 3, 4, 5, 6, 7. There's another way of drawing this. We call it Lewis structure. Some people call it skeleton. Let me do the skeleton here for us. So we have this for this, 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 and this for this. So let's insert this, and this. Here we have, if we look at this, we can name it from this place or we can name it from this place. So we have 1, 2, 3, 4, 5, 6, 7. That's the best because it cannot be 6. The highest is 7. And we can also have it as, if we look from here, we have it from left is 1, 2, 3, 4, 5, 6, 7. Then we at position 2 we have bromine. Remember that we should look for where the substituent have the lowest value. The same way, if you look at it, chlorine is the lowest. Now if for instance there is no other substituent like this, we would have used bromine because according to naming of according to alphabetical order, bromine comes before chlorine. Therefore, we are going to name bromine before chlorine. But because we are dealing with something that have another substituent, this substituent, there are 2 here. Therefore, we will use the one that is lower to them than this value. So we are using 1, 2, 3, 4, 5, 6, 7 because of methyl is here and chlorine is here, and they have the lowest value. But if you count it like this, the methyl here is going to be 5 and this is 2. It does not make them to have the lowest value to the counting or the numbering. So we have this to be, okay, that's 7, and the name of the longest CC number is hept. From this, we know that this is all single, but therefore we're using AN, which is N. Parent name now becomes heptane. Okay, let's go for the substituent so that we can be able to remember the substituent here includes Cl, the methyl group, and the bromine here. You know, we're going to call it bromo, and we call this one chloro. This is methyl. Okay, the position here, since we are using the blue, is chloro at position 2 and methyl at position 3. Then the bromo is going to be at position 6. So we have it as. Okay, when we combine this, remember that for us to name this, we are going to follow the alphabetical order. This comes first, followed by this, followed by this. That is a substituent. And you know that we write the substituent first, followed by the parent name and the functional group. So we have the names to be. That's all. Then the next example we are going to go for is the one that has a perfect functional group. You know, we have treated all the ones that does not have a perfect functional group, that have been using E to represent the functional group. Let's look at this last example. As we look at this, there's a functional group here, there's also a functional group here. That means that we also need to look at the order law. One of the last rules is that if we have more than one functional group present, we are going to choose the strongest or the heavier functional group. And as you can see on the screen, we have carboxylic acid to be the highest, followed by alkanoate, followed by aldehyde, ketone, alkanol, alkyne, and alkene. That means that if we have carboxylic acid present at the same time alkanol present, we are going to choose carboxylic acid as the functional group rather and make the alkanol to be a substituent. Now look over here. We have the alkanoic acid sign here, that is the carboxylic acid sign here, and we also have the alkanol sign, and we need to take this because this is stronger than this. Therefore we are going to take this as a functional group, then take this as the substituent. And according to naming of compounds, organic compound, this is the number of carbon we name. Therefore we have 1, 2, 3, 4, 5. This is very, very easy to go because it does not have too many clustered substituents. But we have 1, 2, 3, 4, 5. So the longest carbon name remains 5. Here we go. So the longest carbon chain is 5, and the name is called pent. And if you look at it, we have all single bond in all the carbon. Leave this one. This is not a carbon. This is carbon oxygen. Therefore, carbon are all single bond. Therefore, we're going to use the AN for it. The carbon functional group here is oic acid. Let's look at the substituent too. The substituent. But before we go for the substituent, we need to number this, and I told you that it's a simple one, and numbering is just simple. So we have it as, there is no need of interchanging the color using red or blue, since I know that we are just moving like this, a straight one. Okay, now let's look at the substituent. The substituent, one of them is found at position 3 and one is found at position 4. The one at position 3 is called hydroxyl. Actually, it would have been ethanol group, that is alkanol group, but because it is a prefix, it is going to be hydroxyl group. Then this is called methyl group. So the substituents are, okay, to name these, it is very, very simple. Now we are going to combine both the longest carbon number, the bond type name, and join it together with the functional group. We will have the parent name as. When we join the substituents, we will have 3-hydroxy 4-methyl pentanoic acid. Therefore, this structure we are seeing here is 3-hydroxy 4-methyl pentanoic acid. And I know if you have been with me from the beginning, I made it clear to us that to name organic compound, we need to have the 3 parts, which are the substituent name, or in English, when we are forming what we call a prefix, parent name, we call it the root, and the functional group, we call it the suffix. And we have rules that we are to follow in naming organic compounds. Thank you very much for watching this video to this extent. Don't forget to like, comment, and tell me what you think that I can do in order to make this video to be much better. And don't forget to subscribe. Click on the notification bell for your good, so that my subsequent video will be given to you as a notification, and you can watch and learn more in chemistry. Thank you very much. We're going to have the next video on how to write a chemical formula of organic compound. We'll be right back.